Good morning and welcome to our third Wednesday Parent Resource Chat. We're glad that you've joined us. We are excited to have updates and new information for you to share with you today. But before I get too far ahead of myself, let me stop here and establish protocol by recognizing our Oak Hill CDC leadership, who so graciously has allowed us to bring this information to you. Our president, Jennifer Garrett, our executive director, Pastor Michael O. Minor, project director, Lottie Minor, technology and metrics director, Thomas Duke Robinson III. Well, again, good morning. And today we are so excited to have one of my favorite colleagues present for us today, Dr. Susan Wolford. And just to share a little bit about who Dr. Susan is, so that you can understand that she has more than enough experience and expertise to be here with us today. Dr. Susan is an associate professor in the Division of General Pediatrics at the University of Michigan, where she is a member of the MISHAR Community Engagement Team and serves as co-director for the Healthy Flint Research Coordinating Center, or HFRCC as we call it. Dr. Wolford's research is funded by the NIH, focuses on the use of technology to improve physician-patient communication, particularly in diverse populations. Dr. Susan, welcome.
Thank you so much, Ms. Bettina. Thank you so much for this invitation to be part of this webinar today. And thank you to all of the leadership team who've been bringing such wonderful information to the community. I'm really grateful for the opportunity to be able to speak today a little bit about vaccines and about the virus, about coronavirus, and hopefully to answer questions that people may have, particularly as it relates to children. So should I jump in with the slides or?
Yes, you may start. Thank you so much again for being here.
Thank you. Okay, so I'm going to share my screen now. And hopefully you can all see that. Great. So as mentioned, I'd like to talk about the novel coronavirus and vaccines. And I have lots of information because I was just so excited about sharing this with you. But Ms. Bettina, feel free to jump in at any point. If I need to clarify something or if you want to break in with a question, that would be totally fine. So right. I thought for this that we would go back to the very beginning, to the basics about like, what is a virus? They're really, it's caused so much problems for us, but it's a really very simple element. It's just a small particle that has the genetic material in the inside that describes how it should be made, and a fatty layer on the outside that keeps it all together. It can't even really survive for a very long time outside of us. Now, we've known about coronaviruses for decades, and the ones that we had mainly caused just like the common cold, although there were some more significant ones like SARS and MERS that were quite deadly. But then along came this novel coronavirus that we're dealing with now. And you may ask yourself, well, how do they get their name? They're called coronaviruses because somebody thought when they looked at it under a microscope that it looks like a crown or the corona, that circle around the sun. And if you look at it under a microscope, it kind of does have that ring. And so that's where it got the name, that family of viruses got the name coronaviruses. So how do viruses work? Well, if we think of our body and we think about the cells in our body, what cells do, cells are like factories. They all have a job. Each cell has its job like a factory that it should do. So let's imagine that the factory is to make cars. So that's what that cell is doing. What a virus does is it comes along and it hijacks the cell. It gets in there, stops it from making what it was supposed to make, and instead makes it make parts of itself, and then puts those parts together to make more of itself. And in that process, it kills the cell, but it's made more of itself. And that's how it damages us, and that's how it kills our cells. So the coronavirus, this particular one, this novel coronavirus that we're dealing with now, is really good at getting into the cells in our lungs and in our nose and in our airways. And that's why it causes so much difficulty with breathing and shortness of breath. It can also get into other places as well. It gets into our kidneys. And so that's why it also causes other problems too. Well, how do we fight it? How do we fight viruses? We have a few ways, and I want to mention just 3 of them now. One of them is with white cells called phagocytes. Up here in Michigan, we have a drink called Fago. And so it just sounds the same thing. It's phagocytes. And these phagocytes are cells that come along when they see something that shouldn't be in the body, they engulf it and consume it. Just like we might consume a drink, the phagocytes consume that virus, eat it up, and destroy it. So that's one way. Another way that we fight infections is through antibodies. So when something that shouldn't be in our body gets into our body, we have cells that make these antibodies. The antibodies attach to that virus and attracts the phagocytes to come in and destroy them. And then there's one other way I'd like to mention. These are our killer cells. And some of the cells in our body are very, very wise. When they get infected, what they do is they put parts of the virus on the outside of the cell. This attracts these natural killer cells. They're like, ooh, there's something in that cell that's bad. They come along and they kill it. So it kills the cell that it was in, but it also kills the virus. So that way you can fight off the infection. Well, that's how our body does it. But what immunization does and how it helps is that immunization is self-defense training. It's like a training camp for our body to teach our immune system how to fight off the infection. That's me in my Taekwondo outfit, fighting off the infection. All right, so that's what vaccines are supposed to do. Now, we know that vaccines do this very well because we give kids a host of vaccines to fight illnesses that have been around in the past, many of which we don't see anymore. So we have vaccines for chickenpox and tetanus and pertussis, hepatitis. We have vaccines for all of these things. Some of these things like measles and polio, we don't see at all because these vaccines work so well to train our bodies to fight it off. I want to mention just one particular kind of vaccine because one particular vaccine because it's so dramatic to me how effective it was. So there's a type of meningitis called Haemophilus influenza meningitis that just before I got into residency, we got a vaccine for it. So all the people who trained me talked about how bad this virus was, this meningitis was. And meningitis, as you will know, is like, it is an infection of the layer around the brain. So rather than looking like that healthy brain at the top, it gets all infected and it causes death or it causes very, very severe problems. So in the time before I trained, there were lots and lots of cases of this virus, of this meningitis. And all of my professors were so nervous about this, and they would teach us that if you see these signs and these symptoms, then you have to quickly get them into the ICU and get them treated. I have never seen a case of it. Look at this graph. As you can see, there was a time when the number of cases was very high, and then it dropped off very precipitously. And I know you can tell exactly what happened where it started falling off. At the point that it started falling off, that is where we got the vaccine. And we just don't see as many cases now. And that's what vaccines do. And that's why it's so important for us to be able to use them. So now let's think about the COVID vaccine. Now we're going to talk about the COVID vaccine. I don't know if you want to restart that before I keep going. I'll just pause. I know that there were lots and lots of concerns. I know there are lots of concerns about the COVID vaccine specifically. So let's talk about that one. to think about how well it's working, let's look at deaths from coronavirus. I chose January to June because we have lots of data on it. Back in January of this year, we were losing over 3,000 people a day from coronavirus in the US. By June, we were losing on about 342 people per day from COVID. Of course, a number of things happened in between, but one of the major things that happened in between is that the number of people who were vaccinated increased dramatically. I want us to think about something else, looking at deaths. In June of 2021, the number of people who died per day from flu and pneumonia was 115 people. From diabetes, it was 285 people per day in the US. And from COVID-19, 342 per day. So if anybody tells you that flu and COVID are the same, you can clearly see they are not. We're losing many more people daily from COVID than we are from flu and pneumonia. So let's think about those 342 people dying on average per day in June from COVID-19. There are two types of people. Those who are unvaccinated will have them in blue, and those who are vaccinated will have them in orange. So here we have 342 people. How many of those people on average do you think were vaccinated versus unvaccinated? I will tell you that all but 5 of them were unvaccinated. See the sea of blue of unvaccinated. Vaccinated people are far less likely to die from coronavirus than unvaccinated. Just a few points about children. We know that the mainly people who have the cases and death, it happens for adults. And here we have adults in blue. But we also see that in the light blue. We also see in the dark blue that it does affect children as well. And those numbers are increasing. And I wanted to just show, looking at the cases of coronavirus in children by region. So we're talking about the number of children who are positive for COVID on a weekly basis, and we're looking at them in regions. So the Northeast of America, the Northwest, the West, and the South. And for each one, we're going from April to August, because that's where we have data. So if we look at that, you will see that it ebbs and flows. But do you see that very high spike over here on the right for the South? These are cases in children going up dramatically. And we see that it's happening more in areas where they're not vaccinated, where the population is not vaccinated very well. We know children under 12 can't get vaccinated, but of course the vaccination, whether adults get vaccinated, impacts whether kids are going to be exposed. And then those children 12 to 18 who can get vaccinated, whether they are or not, as well has an impact. And we can see the areas where it's not happening as much. One other thing about children I'd like to mention, that while it is rare, there are severe outcomes for children who get COVID. And so there is this multi-inflammatory syndrome in children that we see. And lots of different symptoms, but generally fever, abdominal pain, neck pain, vomiting, diarrhea, fatigue. Often you'll see that they have red eyes, that they have swelling of their hands and feet and a rash that goes along with it. Swollen lips and tongue, and then they're usually very, very sick. And one interesting point I wanted to bring out about this is that who is it affecting? So if we look at the cases of this MIS-C by race and see who it's affecting, we see that over 30% of the children who get MIS-C are Black. Just about 30% Hispanic and a little less than 30% white. You might say, oh, it's evenly distributed, but Blacks only make up 13% of the population, but we're making up over 30% of the cases of MSC. This just reflects the fact that COVID is really impacting Black and brown communities a lot more than others. So we have to be very concerned. Okay. One last thing I would like to talk about before we go into taking some questions is about masks. Because as I mentioned, many children can't take the vaccine. If they're under 12, we don't currently have a vaccine that they can be admitted, that they can receive. So how do we protect them? Masks are one of the best ways that we can do that. We should get the vaccine, and then we should put masks on and put masks on them. And I want to point out that we do a lot of things for safety, right? We'll put a life vest on them. We wear shoes with enough padding. We do things for safety, and we want to keep our children safe. We put kids in car seats, confining them. How many kids in the beginning like to be in the car seat? Not so many. We face them backwards. They can't see their parents' expression. They can't interact as well as they want to. Many of them don't like it. We put them there because it's safer. We don't let them sit in the front seat, even though every kid when they're little wants to be up front with their parents. We don't put them in the front seat because we know it's dangerous. We make decisions for them that help to keep them safe. We make people drive slowly when they're in school areas. And all of us are used to being stopped by a traffic light. We don't have the freedom to just go through an intersection whenever we want to. Our freedom is curtailed so that we and those around us can be protected. So masks fit into that category. But people have lots of questions about it. They want to know, will their child get enough oxygen? Will they breathe in too much carbon dioxide? Is the virus so small that it won't be stopped by the mask? Don't we need more studies? All of these things are the kinds of things people want to know. Why did they tell us that we didn't need them in the beginning and now they tell us we do need masks? And will it affect my child's language and emotional development? So there are all of these questions. I want to answer them today, starting off with affecting the language and emotional development. The studies suggest that there is no negative impact on children's language or emotional development from adults or children wearing masks. Most of that language development is happening between birth and 2 years of age, and the mask recommendation is for 2 and older. So a lot of the language development has happened already. That they get a lot of emotional expressions, etc., outside of school when they're at home and when the people are not wearing those masks. They can see it from people on screens, even in the classroom. And their language, children who are vision impaired actually have great language skills and they can't see anything. So there is no reason to believe that them not being able to see somebody's face or mouth will impact their language and emotional development at the ages at which we're asking this to happen. And this is specifically for children without neurological problems. If there's a neurologic concern, then we have to be sensitive to that and make special accommodations. But these are for children who do not have any special neurologic concerns. And so then why did they tell us in the beginning that we didn't need masks? And now they tell us we do need masks. Well, this is one of the best evidences I think you can have that masks work. Because in the beginning, we didn't have enough masks. And because masks work, they wanted to save the masks for those who were at greatest risk. So frontline workers and first responders, those in hospitals, they wanted to save the masks for them so that we could keep that workforce safe because we know masks work. So now we don't have a limit to masks. We don't have a deficit of them. And so we can now open it up for everyone to use them. Also, we know a little bit more about the spread of coronavirus. We're learning more. Anytime somebody shares information with you, think of it about COVID. Think about it a bit like a weather report. What they tell you today is right for today, but things may in fact change tomorrow. And it doesn't mean they made a mistake yesterday. It just means we have more information tomorrow. So we have more information about coronavirus now and how it's spread. And we continue to know that masks work. So that's why in the beginning, they said, oh, you don't need to wear it. But now we're saying you do. Don't we need more studies? Absolutely. I'm a researcher. I will never say we don't need more studies. But we work with the information that we have. And based on the information that we have right now, it's very clear that these masks are a good thing for us to use. So I'm going to take the last 3 questions here, all in one go. Will my child get enough oxygen? Will they breathe in too much carbon dioxide? And is the virus too small so that it won't be stopped by the mask? So these are things that we have to answer by knowing something about the size of the virus. So if you take this ruler and look at the smallest division, the little millimeter on the end, if we take that millimeter and we divide it in 1,000 little pieces, and then we cut one of those pieces 10 times more, that is how small coronavirus is, right? So it is tiny. However, even though coronavirus is tiny, oxygen and carbon dioxide is even smaller. So if we said this little dot over here is oxygen or carbon dioxide, if we got 10 times bigger than that, and 100 times bigger than that, and coronavirus is 1,000 times bigger than that. So the difference in size between the virus and oxygen and carbon dioxide is vast. So oxygen and carbon dioxide can get through spaces that the coronavirus may have a harder time getting through. So to think about whether masks work, we have to think about the little spaces in the mask that let oxygen in, carbon dioxide out, but keeps the coronavirus in. So those little holes, if you happen to have one of the KN95 masks, that is about 3 times bigger than the coronavirus. If you have one of the regular, like surgical masks, then it's about 4 times bigger. So I want to do a little demonstration here to hopefully clarify this. I'm going to stop sharing and I'm going to get my little strainer. Now, imagine that this is a mask with little holes in it, obviously, so we can see these. Let me get my bowl here. So this is a mask. And this, my little sugar sprinkles here, tiny little sprinkles, is oxygen or carbon dioxide. See how they'll readily go through there. That's how oxygen and carbon dioxide get through a mask. So it doesn't build up carbon dioxide inside us. No studies show that it does that. It lets oxygen come in very easily. All the studies show that our oxygen levels are very good, even when we're wearing masks. Goes through so simply. Now, imagine that these larger sprinkles are coronavirus, right? Can that get through the mask? So you see, some of it would get through, but not as easily, not as much. Here is the genius of how God made us. These marshmallows are respiratory droplets, the mucus in our airway, right? Notice these cannot get through the mask. Those respiratory droplets that are in our noses and in our mouths when we cough and when we sneeze and when we breathe out, that can't get through. And this is the genius of the way we're made. Coronavirus doesn't come out as single little coronavirus particles. It comes out embedded in the respiratory droplet. So it can't get through either. So it's not getting through because it's getting stuck in the mask. And that's how the masks work. That's why we should wear them. It protects us because it keeps those respiratory droplets there with the coronavirus inside, so we couldn't spread it out. And if somebody else coughs and sneezes, it won't come through to us. But at the same time, it lets oxygen and carbon dioxide in and out so that we can breathe easily and keep ourselves safe. So as you're sending kids to school this fall, 1, everybody who can be vaccinated should be vaccinated. 2, wear a mask. And then, of course, wash our hands, stay physically distant, try to have the best ventilation possible, have all those layers of protection. And of course, we pray, but we pray and do all of the best things that we can to keep ourselves safe. So with that, Ms. Bettina, I'd be happy to take questions.
Awesome, awesome. So as Dr. Susan has said, she's ready to take questions. So if there are any questions, you can either put them in the chat or you can open up your mic and ask your question, and we'll be happy to have them answered your questions today. I'm going to start off because I like to know how adolescents who've been vaccinated against COVID-19, how are they doing so far?
So from the studies that we have, it appears that they're doing very well. We know that, sorry, I just seen the question that came up. We know that the vaccine seems to work just as well in adolescents as it does in adults. It's important to note that when we say these vaccines work well, that vaccines, like when we get the flu vaccine, it is about 40 to 60% effective, right? And we're happy with the flu vaccine most years. Some years not so good, it's more like 40%. Some years it's better, it's more like 60%. These vaccines for COVID-19 are more like in the 90s. That does still mean that some people who get the vaccine will still get ill, but not nearly as much as if you didn't get the vaccine. And so the adolescents appear to be doing very well with the vaccine as just as well as adults. Now, when you get a vaccine, of course, you get a bit of a fever, some pain at the site of the vaccine. You may have fever and chills the following day. That means that the vaccine is working. Your immune system is kicking in and it's learning how to fight off this infection. So they'll all get that. There were some cases of adolescents, not so much adolescents, but younger people, maybe in their 20s and 30s, and some adolescents having a cardiac response to the vaccine. But this is the same kind of thing that can happen if you get a virus. And generally with treatment, those children do well.
Someone wants to know what's in the vaccine.
I am so glad you asked that question because I want to show you this. Vaccines, particularly, let's start with the Pfizer vaccine, and the Moderna one is really very simple, very similar. But when we think about a vaccine, these ones have very few ingredients. I want to have you think about the vaccine much like this Hershey's Kiss. See this piece of paper in the middle? Let's imagine that those are the instructions to make the messenger RNA, right? This genetic material. So it has that genetic material instruction. That's one ingredient. The same way that this little tag is surrounded by all this chocolate, this fatty chocolate, the vaccine has that genetic material and it's surrounded by a layer of fat. So it's different fats that they put in there. Cholesterol is one of them, but it's surrounded by a layer of fat. They also put some salt in there. Some of it is sodium chloride, but some other salts like potassium. They put some salts in there. And then they put some sugar in there. It's a different, some is sucrose, some use other kinds of sugars, but they have a kind of sugar. They have a few different salts. They have a fatty layer, and they have the genetic instructions for the vaccine. Really very few things. That's why the Pfizer vaccine has to be kept at such low temperatures because it doesn't have all those preservatives and all those other things in there. That's why if you've ever heard that they had to keep it really, really cold, that's the reason why. They didn't put very many other things in there.
So there is a question about when will the Moderna vaccine be available for ages 12 and up? And then someone says, tell us about both shots. So I know that Pfizer is already available for booster shots, but do you have any idea when Moderna will be available?
I really don't know. I know that I heard on the news that maybe we'll get the Pfizer for the younger children, or at least a decision, or that they'll go to the FDA either next week or that week after. They'll start putting the information into the FDA. As far as when we'll have Moderna for either the booster shot or for younger children, your guess is as good as mine.
And I think that kind of says this is what may possibly be the holdup in FDA approval of the Moderna vaccine.
So I'm not sure that there's actually really a holdup. I think that what generally happens with these vaccines is that we test them in adults, and then when it works in adults, then you test them in younger children. And part of what you want to determine is what dose do you give? So are you giving the same dose as adults, or do you give 1/10 of it? And at what age do you make that cut? So it takes a little while to get that research done. And then you also have to get enough cases to be able to see if it's protecting against those cases. So I think it just takes some time to get that. So I don't think it's a holdup, but I do think it should be encouraging that they're doing all the steps that they need to be sure that when we give it to children, that it will be safe.
Wonderful. So another question asked, will wearing masks for a long period within a day cause physical harm to you?
Absolutely, absolutely no. Surgeons wear masks for hours on end, doing very lengthy surgeries, and they are fine. In fact, their brains are working very well. At least we hope they are, right? Because they're doing such complex work. So no, as I tried to demonstrate, the oxygen goes through the mask very easily. It goes in and out easily, and the carbon dioxide gets out easily. Some people have said that right behind the mask, if you test the level of carbon dioxide there, it may be higher. But when we check people's bodies for high levels of carbon dioxide, there is not that. There's no higher level of carbon dioxide in your body and no lower level of oxygen. So it's safe to wear it for as long as you need to wear it.
Okay. Well, I have a question because it's been this talk about, well, if you've been vaccinated, you can still get COVID. So why should I get vaccinated? What may cause COVID to be a breakthrough?
So there are two things I'd like to say to that. One, that if you get COVID and you are vaccinated, your likelihood of being hospitalized or dying is infinitely less than if you got COVID and you are not vaccinated. Hark back to the picture I showed you of how many people who are vaccinated die versus how many people are unvaccinated. The deaths and severe cases of COVID tend to be in those who are not vaccinated. So that is the first. Even if we would get COVID at the same rate as others, the reason to be vaccinated would be that you are less likely to get hospitalized and die if you have the vaccine. The vaccine is very good at protecting against that. Secondly, you are less likely to get infected. And if you do, it will be mild. Now, as I said, remember, when you hear anything about COVID, think about it as a weather report. It is accurate for now, and there will be more information or somewhat new information tomorrow because things change over time. One of the things that's changing are the variants. And so we're constantly checking to see, is the vaccine as good against the variants as if it was against the original coronavirus or COVID-19. And so far, they're still doing very well. They're still better than flu. They're still better than 40 to 60% against all of the variants that are of concern at the moment. In 3 months, 4 months from now, 6 months from now, I don't know whether there will be new variants, but at the moment, they are hanging strong.
Wonderful. Thank you so much. So it would seem that it would be wise to really give some serious consideration into getting vaccinated.
Absolutely.
And how should we start the conversation with our children when they come home and they want to know why we got to wear masks in school and stuff? What is a good way to start a conversation with them about COVID?
Yeah, so I think that's an excellent question. I mean, of course, all of these things depend on the age of the child, right? So we have to do it at the developmental stage that's appropriate for the child. For adolescents, one can have a very frank conversation about all of this. They've been hearing it on the news, they're hearing about it at school, so they know. So we should convey this information that we believe that science shows that masks keep us safer. We have enough evidence of it. We can look at other countries where they wear masks more than we do, and how much lower their prevalence is of COVID. So we can give them all the evidence, and they can be part of that decision making and know that we want to keep our family safe, but we also want to keep others safe. And we are our brother's keeper. So if you're young and you're likely to get coronavirus and you're likely to do just fine, that's okay. But if you get coronavirus while you're doing fine, you might spread it to somebody else. And as you spread it to somebody else who's older, sicker, otherwise has health conditions, then that person may have a very, very poor outcome. Do we want to do that? Isn't it our Christian duty to do our best to protect others as well? So you can have that conversation in depth with adolescents. As kids get younger, we don't want to worry them, right? I mean, I do a story time with children on Sundays, and these young people, they're like 7, 6 years old. And when they pray, they all pray to keep everybody safe from coronavirus. I mean, they know it's out there and they know that it's killing people, right? But we don't want them to be walking around in fear. So we tell them that, yes, there is something that can make us sick, but we have good ways to help keep ourselves safe. And little kids like wearing the mask, where they can have little, I don't know, superheroes on them and animal shapes. So you just have to have that conversation at a level that's appropriate for the child.
Wonderful. Thank you so much. Are there any other questions for Dr. Susan? Because I have one more I want to ask, but I want to make sure everybody gets their questions answered. So are there any other questions?
There's a raised hand, I think.
I'm not seeing it.
It says,
if there's a raised
hand,
hand, would you open your mic and go and ask your question, please?
Thank you. Good morning. Can you hear me?
Yes.
Okay.
My question is the younger children's that's kindergarten and first graders that has contracted the virus, what percentage affects their lung after the fact?
I didn't hear the end of it. What percentage did?
What percentage affects their lungs?
Oh, the lungs
Yes.
afterwards. Yes. So I believe it is a very low percentage. I don't know that we know the numbers, but we do believe that the risk. So with adults, this long haulers, where people have these long-term problems with fatigue and shortness of breath and cardiac problems, that issue of long haulers happens less in children, but it still happens. But I don't know that we know the percentage for that yet. It is low.
Okay. Thank you.
There's a question that says, some people are complaining of facial breakout from the mask. Are there some better to use than others?
Yeah, that's a great question. So if you find that it breaks you out, then try a different material, right? So you may have to go through different ones. I think that the KN95s may be less likely. I find them softer than the surgical ones, but then there are also the cloth ones, because any mask is better than no mask. So while yes, the surgical one might be great, if that's causing you to break out and you can't wear it and you have to wear a cloth one instead, then go for the cloth one. But yes, try to find the one that works for you. And then when you're not indoors or you're not around people, then of course allow the pores to breathe more and not to have it on. And sometimes putting on a barrier cream might also help.
Are there any special barrier creams that they should use, or just barrier cream?
Just barrier cream.
Okay. Now the last question here says, what's the difference between Pfizer and Moderna?
So if your question is in regards to what is in it, like the ingredients, they're very, very similar. They have the genetic material, they have the fatty layer. It's like different
You
fats.
on the Zoom?
It has the sugars, but different sugar. And they have salts, but different salts. The one other thing is that Moderna has acetic acid, which is like vinegar, a little bit of that in it too. So it has one additional ingredient in Moderna that the Pfizer doesn't have. but they're very similar. And the way they work is really, really similar. In fact, do I have a couple minutes to show you how they work?
Yes, go ahead.
Okay, let me share my screen and I'll share a little bit about how they work. Hold on. Let's see if we get there. Ooh, am I getting there? Okay, so remember the virus has like this fatty layer, and on the inside is the genetic material that tells the virus how to make itself. If it's a coronavirus, that recipe tells it to make the coronavirus, which has these spike proteins. You guys have heard about spike protein. So that's what this coronavirus has, these spike proteins on the outside. That spike protein is really central to what happens because that spike protein is really good. It's like a key. It's good at unlocking the receptors on our cells. So that spike protein is the key. It unlocks our cells and opens up our cells so that the coronavirus can get into our cells and do its dangerous work. So with the vaccine, what happens is the vaccine puts in that recipe to make just the spike protein, not the whole virus, just the spike protein. It puts that into our body, that goes into our cells, has our cell make spike protein on the surface of our cells. That recipe to make the spike protein then goes away. It is destroyed by our body. It does not go into our nucleus and change our DNA. It just is destroyed by our body. But those spike proteins stay around for a little while, like a couple of weeks. And during that time, our body makes antibodies that learn how to fit very well over that spike protein so that that spike protein, when it comes into our body again, cannot be used as a key because those antibodies will be able to block it. The other thing our body does is it trains our T cells, it trains these killer cells to recognize that spike protein and to know how to come in and kill any cell that has that spike protein on it. So when coronavirus comes in, like we come in contact with it, we go to church and somebody has coronavirus and we come in contact with it, our body now knows that spike protein and it immediately makes the antibodies, attaches to it, so that cannot be used as a key. It cannot unlock our cells to get into our cells. And those T cells that were already trained come along and recognize that spike protein because it saw it before, kills the coronavirus, and we don't get sick. So that is how both of those vaccines work, both the Pfizer and the Moderna, by putting that little instruction in us as to how to make the spike protein and train us how to fight it off.
Wonderful. Two questions. One says, are you able to address when the flu vaccine should be taken in relation to the corona vaccine?
So previously we were saying that we would separate vaccines, and the coronavirus we're doing 2 weeks after other vaccines. But now there isn't a restriction. You can take them, and they're both available now, so you can go ahead and take it.
Wonderful. The other one was, can they get slide presentation?
Say one more time.
They want to know if they can have access to the slide presentation.
Well, I'll get a version to you that you can try to make available.
Okay, and I will share that with them in just a minute where they can go to see the slide presentation and any other information and resources that we have with regard to this webinar today. But the last question I want to ask is, we've worked together for a number of...
first, Ms. Martina?
Pardon me?
Can I ask my question first? I wanted to know, if you don't mind, I was just waiting. How you doing? I enjoyed everything. I want to know, I've had my two vaccines. They were saying about the booster at my age I'm just going to say between 65 and 70. Do I really need to get the booster? You know,
Oh,
I've had my flu shot.
You had your flu shot and you've had both doses of the vaccine.
Yes.
So this question of whether you need a booster is right. Whether you need a booster or whether you need a third dose.
Right.
So for those who already had the 2 vaccines, but they were somehow immunocompromised. Their bodies, their immune system isn't as strong and possibly didn't react in the way that we wanted it to, then those people already should go in and get a 3rd dose, right? So if you fit into that category, that's already been said, and you should definitely go ahead and get it.
Okay, thank you so much.
For those who were not immunocompromised in some way, for those who had the first 2 vaccines and probably mounted a good response, then there is the thought that they will recommend a booster, but they haven't come out with the final statement on that. So that's one of those things we have to wait for and see whether all of us will be told that we all need to get a booster shot 8 months or 9 months or 10 months after we finish the first course of it. But we kind of have to watch this space for a moment.
Okay. Thank you so much, God bless. Thank you, Ms. Martina. Thank you, Ms. Campbell.
You're welcome. There is another question that has come in that I think would be good to answer. Since my son got COVID vaccination and 4 days later was diagnosed with having COVID, does this make symptoms worse?
Does it make worse that they got the vaccine in between?
Yeah.
No, it probably shouldn't have made his symptoms. It probably shouldn't have made his symptoms worse. It just means that he hadn't developed his immunity yet when he came in contact with the COVID. So he came in contact with COVID either just before he got the vaccine or maybe just after, but he hadn't, because you're not fully protected until 2 weeks after your 2nd dose of the Moderna or the Pfizer, because it takes a while for all that training to happen. So it wouldn't have made him worse.
Well, thank you. One of the things that that I know that we've worked together for a long time, so I feel comfortable asking you this question because I do know your background that I didn't share with the audience, but there's a lot of talk about faith and and how faith should play in getting a vaccine or not getting a vaccine. And I know that you are a first lady, and I know that you have a strong faith, and it's come through today as we've talked. I want to know, how do you reconcile being a doctor and a researcher with your faith?
Thank you so much for asking that question, Ms. Bettina, because it is central to my life. I believe that God made science, right? He created the earth, he created everything in it, and so he knows how it works. So science is just trying to learn more about God and how he created things. We learn about him in the Bible, we learn about him from nature, we learn about him from science. And so I think that the study of science is fully in keeping with having a life of faith. And I will say that when this coronavirus hit, I mean, we all know that pestilence will come, right? We've read Matthew 24. We knew that some things like this were going to happen. But when it happened, of course, we were, oh my word. And we all turned to our Bibles more. We all turned to Psalms 91 and claimed the promises of his protection. And I still do. When the vaccine came out, I have to say, while I am fully, completely, and I know this video is going to be saved, so I want to be sure that I say this, I fully believe that vaccines work. When this vaccine came out, I was a little bit like, I'm not sure I want to take this. And so what do you do when you don't know what to do? You pray. So I prayed, and I kept feeling the Lord telling me to take the vaccine. And I kept saying, Lord, I'm afraid. And then one day I was in clinic and I had to go in and see patients who probably had COVID. And I'm like, you're doing this without being vaccinated. This doesn't make any sense. And God is telling you to take the vaccine. So why are you not taking it? That's a spirit of fear. And God hasn't given us a spirit of fear, right? So I prayed again, got again the firm belief that God was telling me to do it, and went ahead. And I'm really glad I did. My protection doesn't just come from the vaccine. There are all those different layers of things that we do. Ultimately, my safety, my life, my everything comes from God. And all of us have that resource, right? I'm fortunate to be at a university where I'm involved in research and I can learn all of that, but all of us have access to God. So we pray to him and he will direct us. We'll hear a voice behind us, as Isaiah 30:21 says, saying, this is the way, walk ye in it. We just have to listen to that voice.
Wonderful testimony. Okay, are you aware of the HHS Health Equity Council?
Not specifically. I'm aware of some equity committees and programs. I'm not sure. I think that might be the one that Dr. Holden is part of, but I'm not certain. Is there something about it?
No, that was just the question.
Oh,
okay. Well, thank you so very much. You have really enlightened us today and given us information, reaffirmed some information, given us new information that we need to try to help us make the appropriate decisions for our health and the health of our children and our other loved ones. And so I want to thank you for being here. And for the viewers, you will have additional information and resources on our Healthy Kids Mississippi webpage, www.healthykidsms.org. The Facebook page is Healthy Kids Mississippi, our Twitter feed, and of course, later we'll have it up on our YouTube channel. Again, I want to recognize our Oak Hill CDC leadership and give thanks for them for their continued support for allowing us to be able to bring you this information every third Wednesday. And that's, again, President is Jennifer Garrett. Our Executive Director is Pastor Michael O. Minor, our Director Lottie Minor, and Technical and Metrics Director, whom I couldn't live without, is Thomas Duke Robinson II. So I want to say a great big thanks to you for being with us today and asking the questions and having the knowledge to seek the questions, to seek answers to the questions that you have and not just sit at home and wonder. So thank you, and you continue to have a blessed day. Those of you who are on Zoom, will you stay for a few minutes? We're going to go off.
Bettina,
Facebook. Yes.
we want to acknowledge Teresa Zayas, who is here with us from CMS today. And I apologize, I'm not on the screen or not at you probably can tell I'm speaking from my cell. We had a quick power outage earlier in the webinar, probably 40 minutes ago. And it only lasted for about 3 or 4 seconds, but everything went berserk. So that's why I'm speaking from my phone. But at any rate, if we can allow Teresa to have an opportunity to have a word if she would like to, I think that would be certainly appropriate at some point before we sign off.
Of course. Go ahead, Teresa.
Well, good afternoon, everybody, and thank you for giving me an opportunity to provide some messages. Thank you so much, Dr. Wolf, for that presentation. Was powerful. And I was the one who asked about if you knew about the Health Equity Council. You know, we have a very active Health Equity Council, and one of the priorities is COVID-19. And I would like to, if we can continue this conversation, on another time with Dr. Rochanda Ivory. She is the minority health analyst for the region. And we're having local conversations with stakeholders to talk about this same information that you just presented today and to make connections to find federal resources to help local efforts. So you will be hearing from me soon. I will follow with you. I love how you presented the information. For me, it's like, I'm on those CDC meetings and HHS meetings, and you broke it down in such a way that it is instrumental to share, from my opinion, how you presented this information to other folks.
Praise God. Praise God. Thank you so much.
You're a great messenger. Okay. Thank you so much.
Thank you. So that's my number that I put in the chat for you. So you can.
I will call you. Thank you so much.
Thank you.
Thank you for the connection, folks.
Awesome.